So this is for the force standard. So in this problem, we have a person who went rock climbing and he got stuck in a narrow vertical chimney of rocks. He was supported by his weight by leaning with his back against one wall of the chimney and pushing off of the opposite wall with his legs. His left leg made a 26-degree angle with the horizontal. The coefficient of friction between his back and the chimney is 0.508, and they're asking us to determine the minimum amount of tension which would be required to support the weight of his 86-kilogram body. So we have to find the tension and the normal force of the chimney wall up against his back. So we know that theta is going to be 26 degrees. They give us our coefficient of friction, and they give us his mass. So we're going to draw the force diagram, and we're going to see that we have the force of friction going up, the force of gravity going down, the normal force is going to be perpendicular to the wall, and the force of tension is pushing up to the right at 26 degrees. So we're going to take the force of tension, we're going to break it down into our y and our x. So if you come over here, we can see that our force of tension in the x direction is going to be t times the cosine of theta, or adjacent over the hypotenuse, and our y is going to be t times the sine of 26 degrees, which is our opposite over adjacent. Then we can see that since the force of tension in the x direction is equal to the force of normal in the same x direction, because he's not moving, we can set the force of normal to t times the cosine of 26 degrees. Then we're going to look at our y components, and we know that our force of gravity is going to have to equal the force of friction plus the force of tension in the y direction, because he's not moving, because he's staying in the same place. So we found our force of gravity by multiplying his mass times 9.8 meters per second squared to get 842.8 newtons. That's going to equal the coefficient, which is 0.508, times the normal force plus t sine of 26 degrees. So now we have two equations with two unknowns. So we're going to substitute the force of normal for t cosine of 26 degrees because we have those two unknowns, so we're going to make an expression. So if we do that, we get 842.8 newtons equals 0.508 times t cosine of 26 degrees plus t sine of 26 degrees. Then what we're going to do is we're going to multiply cosine of 26 times 0.508 to get 0.457 times t, and we're going to add that to sine of 26 degrees times 0.508 to get 0.438. We're going to add those because they have the same variable to get 0.895 times t, and that's equal to 842.8 newtons. So we divide by 0.895, and we get the force of tension to be 941.8 newtons, or 942 newtons. So then we still have to find our normal force, and when we go back up to our equation for the normal force equals t cosine of 26 degrees, we're going to plug that in to get 846.7 newtons as our normal force.